A science reporter brings science to people in a way that is inviting yet accurate, who engages the audience through dramatic storytelling. Hello, I'm Paul Doherty, Senior Instructor in the Department of Journalism at the College of Media, Communication, and Information. I really consider myself to be a science communicator, presenting science topics to a diverse audience. Science journalism is a form of news reporting, although it's evolved into a professional field of science communication that includes science exhibitions, journalism, and media production. To me, communicating science is not so much about reporting the findings of science, but explaining methods and framing that into stories that entertain as well as educate. With student involvement, I produced the documentary series CU Science Update, which showcases the science and research being done here at CU. I find that the way to make science accessible to a broad audience is to make the scientists relatable, to avoid their usual academic lectures and show their excitement and passion, which I think will generate empathy in the audience that will get them excited about the subject.
Soaring. The future of science breaks the chains of gravity. This aircraft flies under the control of a pilot
That's way out of there, Taylor.
who remains earthbound.
I did this for fun from my early teens, and I would go out to the model airfield and fly planes and helicopters and all that, and that's what I did on the weekends.
In the 19th century, as science became a profession, there was a greater need to communicate science to a wider audience, not only in traditional newsprint, but also in weekly periodicals like the Penny magazine, published by the Society for the Diffusion of Useful Knowledge. There were other ways to convey science. In England, the public was even encouraged to attend lectures at universities like Oxford and Cambridge. The famous Royal Institution Christmas lectures that began with Michael Faraday in 1825 are now broadcast every year in the UK. In America, the public got to see traveling lectures that also demonstrated scientific experiments. Publications on a variety of subjects also helped scientists communicate their achievements to each other. But it was after World War II when many more popularizers of science became household names. David Attenborough, Arthur C. Clarke, Francis Crick, Richard Dawkins, Sir Patrick Moore, Isaac Asimov, Olivia Judson, Carolyn Porco. The list continues to grow. Isaac Asimov may have written over 200 science fiction books, but he also wrote books about science. In middle school, I read Asimov's The Search for the Elements, a book about the history of chemistry, and it made me want to care about the periodic table. In my work with students, I try to encourage them to bring out the scientist's passion, to find their humanity, and avoid the sort of dry textbook language that can often bog down a good story. This happens when people talk science, using all its jargon, which fails to hold anyone's interest. Tectonics, mitochondrion, albedo, phenotype. You're not likely to hear these words spoken in everyday conversation. To a journalist, it's not just about translating the jargon, but it's about knowing the scientific concepts and then molding them into a story that appeals to a broad audience. Basically, if you want to tell a good story, keep the wording simple, keep one idea or one breath per sentence when you write. Yes, it does take a bit of creative writing skill, but as I tell my students, cut loose, have fun with telling the story. Make it memorable.
It may not look like much, but this is the first close-up image of Mars, taken by the Mariner 4 spacecraft in 1965. 50 years later, the first images of Pluto, sent by the New Horizons spacecraft, a spectacular contrast. But this is the image that says it all. The New Horizons team, reacting to the first photos of Pluto. A moment played out dozens of times in other missions, always starting with tense anticipation.
There is a certain tension, and when we see those first images, I mean, the excitement in the air is pretty awesome.
The best science reporters often use metaphors and images that make the science compelling and accessible. For example, the ozone hole is strictly a metaphor that describes the low density of ozone in the stratosphere taken from measurements over a period of time. The ozone hole was made a household phrase by Frank Sherwood Rowland, a professor of chemistry at the University of California, Irvine, who did work on atmospheric chemistry and chemistry kinetics. A mouthful. Rowland suggested the metaphor to New York Times science writer Walter Sullivan. He ran the first story on the ozone hole in November of 1985. In his lead, Sullivan writes, "Each October, the data show a hole appears in the ozone layer there, scientists say, and each year the layer in that area becomes less able to shield the Earth from damaging solar ultraviolet rays." Walter Sullivan is regarded highly as the man who made the world of science accessible. He was considered the dean of science writers, the man who pioneered the craft. He covered numerous stories about physics, chemistry, geology. His stories didn't have to rush into print like regular news stories. Sometimes their publication would be held up for months, not due to political interference, but because he wanted to get the details right. Sullivan was also a prolific author. He wrote Quest for a Continent, about Antarctic exploration, of which he visited the continent 7 times. And he wrote the bestseller, We Are Not Alone, about the search for extraterrestrial intelligence, among many, many other books. Although he won several writing prizes, Sullivan was also awarded the coveted Public Service Medal of the National Academy of Sciences, which was never before presented to a journalist. The American Geophysical Union even names its Science Writing Award in honor of Mr. Sullivan, who died in 1996. Those who want to learn the craft of science journalism often turn to Walter Sullivan as their guide. The way he explains science, turning it into an adventure of sorts, finding the conflict and making it a human story, all about the struggle to find evidence, to construct a theory. Sullivan put great care into interpreting the complexities of science, and he was the inspiration for many of today's science journalists. But for many of you watching this video, you probably remember Bill Nye, the science guy. He made science cool. Bill Nye mixed science with comedy, and he was filled with this insatiable enthusiasm to educate. To me, my inspiration was astrophysicist Carl Sagan. Sagan is known as the gatekeeper of scientific credibility. He had this astonishing ability to communicate. In 1980, he presented the groundbreaking series Cosmos, A Personal Voyage. The series was nothing but transformative. To me, it helped shape my critical thinking skills and my love for science. Another show that I grew up with and really admired was a series called Connections, written and presented by science historian James Burke. In the 1960s, Burke joined the BBC's Science and Features department, where he established his reputation as a science reporter. He became the BBC's chief reporter on the Apollo moon missions. Connections was produced in 1978. In each episode, Burke guides viewers on a sort of detective story through human history, seeking clues in the past that would lead to innovations, sudden twists and turns, and accidental discoveries that culminated later into a modern scientific achievement. Burke's presentation style was nothing like you'd expect in a science program. Elegant yet witty, James Burke produced a narrative that was compelling, entertaining, and it was accessible, with a tone and style that connected with the audience.
Over the next few years, Wilson, the magic cloud maker, got really turned on by really bad weather, and in particular thunderstorms, and in very particular, the situations where things got really spectacularly bad. And so he was to be seen risking life and limb by poking his instruments as close as possible to gigantic lightning strikes in order to find out how much power they gave off. And if you're wondering why I am telling you all this in the front end of a wartime B-29 bomber, well, one of the reasons is that as a result of Wilson being so interested in lightning, wartime flying was safer, if that's the right word to use.
When we explain something that is complicated, there's this interplay of the rational and the emotional, the head and the heart, as described by Thomas Jefferson. To understand something as complex as science, the head and the heart have to work together. It's where the heart says to the head, "Help me carry out my softer aims, and I'll help you soften the edges of science." The actor Alan Alda wrote about this interplay in his recent book, If I understood you, would I have this look on my face? Many people remember Alda as the star in the television series MASH, but he was a dedicated proponent of science and went on to host Scientific American Frontiers on PBS for 11 years. In Scientific American Frontiers, Alda interviewed thousands of scientists and developed a knack for helping them communicate complex ideas in ways that audiences can understand.
We're here to do some bird watching. Once we spot the bird.
It's hanging underneath the fuselage. It's black. You'll see it when it gets airborne.
Oh, I see it, yeah. The bird is actually a glider built by this man, Bob Hoy. Watching with me is Paul McCrady, who's been encouraging Bob in his quest to design a glider that can soar as well as a real bird. To McCrady's delight, Bob seems to have done it.
That's a real bird.
It really does look real, you're right. Paul McCrady has been watching birds for most of his 75 years. Much of the next hour will be kept in his company as we explore some of the extraordinary accomplishments of a man whose childhood passion for all things that fly has never left him. Paul, why do you do this? What do you learn from this?
Well, first of all, I think everybody is interested in birds. When you're 4 years old and 10 years old and 12 years old, you like to watch birds, wish you could be up there with them.
Look how close he is. Look at it.
In his book, Alda describes the tools of communication that he teaches at his Center for Communicating Science. He found that developing empathy, recognizing what the other person is thinking through their body language, is essential to good communication and good storytelling. We have a fondness for dramatic stories, and if the audience has identified with the character, then they'll develop an empathy for them. Their interest will be engaged, and they'll respond to the story asking, what happens next?
How's this for surreal? Gazing down from the Californian sky at the remains of Eddie Murphy's fictional African movie mansion.
Okay, so
that's it, isn't it?
There it is there.
Alan, maybe we didn't mention it, but you are going to do the flying on the next flight. All of it.
And you're not afraid of that?
No, but we are making it the last flight of the day. Just
you know,
in case.
I have to warn you that I flew a jet in a simulator.
Yeah.
And I crashed it. I actually crashed the simulated jet when I was trying to land it. At least I shouldn't have that problem with the pointer, which goes into an automatic landing mode at the touch of a switch. Oh, wait a minute. Whoa. I thought you were going to hit me with that plane. It looked like it was coming right at us.
Yeah, it was. But that's about the... We could even get closer if we wanted to. It's just I didn't want to hit the cameraman.
Believe me, it's the least of your worries.
Good science journalism reaches out to the public. It should have authority and cultivate not just the public's understanding of science, but to make them care about it. I also think that science journalism should aim to myth bust, to debunk anti-scientific claims. What many in the public don't understand is that science is about uncertainties, not truth. It's about our fascination for the unknown, not about the meaning of life. As journalists, we have an obligation to explain, to be accurate and honest. But as you know, the media likes a good story, especially if it's exciting or controversial. The cloning of Dolly the sheep was an example of both, and it was a great science story. Covered on the front pages and in leading newscasts, Dolly was a media phenomenon. There was novelty in the story, themes that struck at the heart of what it means to be human, fears of mortality, hubris, the subversion of the natural order of things, even one about hope for great medical advancements. The Dolly story also had a great character, a sheep with a father, but no mother. However, the news coverage focused mostly on the consequences of cloning rather than the actual scientific details. The story was framed against existing narratives in pop culture where cloning was stereotyped as having some form of ulterior motive, using images that evoked a sort of biological form of social engineering. And the stories may have even triggered social and political pressure to ban human cloning. But nowhere did the original research mention about human cloning, It was the journalistic interpretation of scientific facts that raised this hypothetical, basically exploiting people's fears that something sinister is afoot. Take ClimateGate, for instance. Leaked emails that did nothing to disprove the science of climate change, yet it sowed the seeds of doubt and undermined the scientific case that climate change is real. These crusades led against the science are not supported by rational argument, but by fear and prejudice. And many reporters, I think, have contributed to this hype by playing to these movements. Those with the loudest voices get the most media attention. But even when overwhelming scientific evidence points in one direction, news outlets still report the fringe views to convey what they call the other side of knowing, to represent both sides equally. The BBC was singled out for giving undue attention to marginal opinion on the subject of climate change and other subjects. It's a situation known as false balance, which is the profoundly mistaken view of conveying marginal views by default as equal and opposite. The BBC changed their policies to prevent false balance. In other words, they stopped inviting cranks onto science programs. But there are many other media outlets that have yet to follow this example. The comedian John Oliver nicely illustrated false balance to show what a representative climate change debate should look like in his show Last Week Tonight with John Oliver. He pitted Bill Nye against a climate change skeptic and then did the math.
Wait, before we begin, in the interest of mathematical balance, I'm going to bring out two people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little unwieldy, but this is the only way you can actually have a representative discussion. So, yeah, please file in. Again, this is going to make the debate difficult. We shouldn't really be having it in the first place. But, representationally, climate skeptic, please make a case against climate change.
Well, I just don't think all the science is in yet. It's settled.
OK, and what is the overwhelming view of the entire scientific community?
It takes a keen understanding on the part of the science reporter of the scientific method and the importance of evidence. That's why when Dr. Andrew Wakefield held a press conference in 1998 claiming to have found a link between the MMR vaccine and autism, it received scant attention from science journalists. On the other hand, anti-vaccine activists targeted their stories to non-science journalists. Their strategy was to represent them as human interest stories, a strategy that worked immensely with some 80% of the stories written by non-science journalists. With the pushback against science from government and the public, the rejection of theories not based on evidence but on gut reactions, science journalists are needed more than ever. But in this hyper-mediated world, it's important not to be taken in by false stories. But even rubbish science, if dressed in shiny ribbons, can end up becoming big headlines. Case in point, science journalist John Bohannon and two German filmmakers scammed the media by purposely putting together a bad scientific study about how dark chocolate, when eaten in combination with a low-carb diet, can help you lose weight. The story went viral, with media outlets around the world taking the bait. Britain's Daily Mail reported eating chocolate can even help you lose weight. It was pure bunk. Bohannon says that reporters need to actually bother with how to cover science. They need to ask probing questions. But none of the reporters who covered this story actually asked an outside expert to weigh in. Bohannon says that their little experiment hopefully will make reporters and readers alike more skeptical. But it also showed that many reporters know very little basic science. The pressure in newsrooms is to publish or perish, and this, I feel, jeopardizes public science literacy. With multiple information sources out there, with partisan news replacing objective media with more fragmented and less comprehensive coverage, with the existence of well-funded, organized anti-science campaigns bypassing the existing science media, more than ever, science journalists and consumers must combat the dangerous misconceptions that are out there, such as the belief that humans are not responsible for climate change, that genetically modified foods are dangerous, that vaccines cause autism, and that humans appeared on Earth in their present form. Simple curiosity and inquisitiveness might make all the difference. In fact, it's called science curiosity, something that Professor Dan Kahan of Yale University says is essential if we're to shape personal opinion. In Kahan's research, people with greater science curiosity are those who are willing to take new information into account when forming their opinions. It was in primary school when I picked up a copy of Carl Sagan's book, The Cosmic Connection, and it taught me a lot about critical thinking. One of Sagan's biggest fans was Isaac Asimov, who once described meeting him in an historic encounter in 1971 with two other science fiction greats, Ray Bradbury and Arthur C. Clarke, and also with science journalist Walter Sullivan. Asimov just finished reading The Cosmic Connection and said he loved every word of it. He sent a thank you note to Sagan, one of many letters that he shared with him, and he said, "You are my idea of a good writer because you have an unmannered style. And when I read what you write, I hear you talking." Sagan found his voice. He made science popular. He understood the influence of television and appreciated the power of good storytelling. Sagan's star shined bright with the 1980s series Cosmos, and it's a show that still endures to this day. The presentation was nothing but remarkable, and you will realize that it's not just a story about science. It's a human story. It's been called a celebration of human curiosity, and that matters. Science filmmaker Randy Olson, in his book, Don't Be Such a Scientist, says that the struggle to make science relevant is the central element to science reporting. Too often, a science presentation is an exercise in boredom, a mistake that seems to be overlooked by the scientific community as long as the facts are right. But good storytelling isn't where the facts speak for themselves. It's how you frame the facts into a narrative that speaks not from the intellect, but from the heart. You have to make the audience care. Cosmos is etched into our collective memory because it touched our hearts. It didn't dumb down the science. Sagan treated the audience as intelligent beings with the capacity to wonder. And the series was visual. Sagan helped the audience see ideas and concepts through the use of his descriptive language and metaphors.
The surface of the Earth is the shore of the cosmic ocean. On this shore, we've learned most of what we know. Recently, we've waded a little way out, maybe ankle deep, and the water seems inviting. Some part of our being knows this is where we came from. We long to return. And we can't, because the cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
I feel that my own writing is strongly influenced by Cosmos, by Carl Sagan. I try to address this sense of wonder and make science something that ignites our curiosity. You know, it's important to take viewers on a journey, to explore using the imagination. Neil deGrasse Tyson, who hosted the new Cosmos, he remarked that the old Cosmos affected you not just intellectually, but emotionally.
So you need to think of Cosmos not as a documentary about science. By the way, since then, there have been many documentaries about science, and it's quite a fertile way of delivering the viewer to the frontier, or bringing the frontier to the viewer. So that's not the issue here, because we all remember Cosmos, and so many of these other documentaries maybe live their moment, but then they fade. Why did Cosmos not fade? It's not because it brought you the latest science, although it also did that. It's because it displayed for you why science matters, why science is an enterprise that should be cherished as an activity of the free human mind, because it transforms who we are, how we live, and it gives us an understanding of our place in the universe. And it's these states of mind that you carry with you for the rest of your life.
For many people, science is hard, It's complex and it can scare them away because we don't always feel a connection to that which is at times intangible, abstract. And there are times I don't blame people for feeling this way. As science journalists, we need to work harder to get people engaged in science.
Sagan made it his life's work to engage the public in the world of science.
Ever listen to AM radio during a thunderstorm? The crackling sound you hear are radio emissions coming from lightning. When you see the flash of the lightning bolt, you also hear the crackle on the radio at the same time. That's because light and radio waves travel at the same speed, the speed of light. Not every lightning bolt is visible. Some are high up in the thundercloud or in another storm miles away.
But you can still hear it on the radio, which make AM radios excellent lightning detectors.
I may not be a scientist, but I'm sure hoping to lure more people to science and show them the universe, to ignite that curiosity in them. Come with me.